Hey guys. Okay, you already read the title, I don't have to repeat that. My name is Bernd Ruecker, I'm co-founder and developer advocate of Camunda. We're an open source workflow automation tool vendor based in Berlin in Germany. We're around roughly 100 people. I wrote a book about BPMN, I'll probably talk about that later on. And what I actually do is I travel around a lot currently at either conferences, discussing stuff a lot, but also customers. I'm doing a lot of proof of concepts, do a lot of solution design discussions and these kind of things. And I actually compiled this talk out of a couple of experience I did within the last years. We will run short in time at the very end, so you have my email address, you have my Twitter handle. If you have any questions, approach me afterwards. I will be here for another hour or so because afterwards I have to leave for the airport. Or you can always tweet me, send me an email. So do that. Just to give you an impression, customer base is basically all the industries. So NASA is actually using Camunda, Goldman Sachs or Zalando or Allianz or T-Mobile or these kind of things. So it's really across all industries, so it's compiled of different experiences. What we see nowadays is that basically all the systems we have out there are getting distributed systems. So just a quick poll, who's doing microservices? Not that much. Serverless, anybody serverless? No. Okay, who is doing at least one remote call, let it be REST or SOAP within his system? Okay, that's actually most of you. There you are. That's already starting to be a distributed system. And I love this metaphor for distributed systems, actually. So there's this rough ocean. That's the network. That's really a bad place to be. That's where you don't want to be there, where a lot of bits are being turned around and these kind of things. A lot of shit happens within that network. Only the small hut over there, that's a good place to be. That's probably your Java program, one JVM. There you probably still have transaction management and these kind of things. So that's really a lovely place for the developer. But whenever you open the door, it gets really rough. And that's what I want to talk about today. And there are a lot of challenges you have in these kind of distributed systems. So I go through a couple of them. One of them is a very easy thing, but a really ugly characteristic of distributed systems. So whenever you do a remote call and you get a network error, let it be like a REST call and you get a network error, it could be like messaging and you don't get a response message, then you have no idea what really happened in the background. It could be that you didn't reach the service provider, you probably reached the service provider, it blew up while it processed your request, or it could be that it even processed successfully your request, but you never got the response. And you have in this scenario, no easy way of really knowing what happened. And you can make very easy example where this gets really a big problem. So let's assume you want to do a payment service. Within the company, you provide the payment service because you deliver orders or whatever you do. And there you use an upstream credit card service, which is quite natural. Normally you don't program that yourself, so you probably use something which is already there, like Stripe or whatever. And you want to call that. And let's assume the credit card service has an error. For the beginning, let's start with a network error. You have a network error there. So the payment service called the credit card service. You get a network error. What could you do? And now you have a couple of strategies how to deal with that. So one possible strategy is to ignore these kind of errors. You could really I remember Visual Basic like 10 or 15 years ago when I started with the Visual Basic, there was an on error resume next. Does anyone know that? I loved it. I started programming that and I always on error resume next. Just ignore it. Is that a valid strategy? I think it can even be a valid strategy. So I gave a talk at QCon, different talk, but similar topic, and then somebody approached me, I have this one service, and it fails like once a week. We lose one message a week, but it's not a big deal. The statistics are not completely correct, but it's not a big problem. And it happens once a week, so ignorance is perfectly fine for that use case. So you have to think about how often and the impact. So ignoring errors, these kind of errors, can be a valid strategy. You just have to make a conscious decision. But what I see happening much more often than ignoring it, nobody really can stand and say, we ignore that error. If you say, on error assume next, like, ooh, that's really bad. Most people just rethrow the error. That's what I see a lot. So if you get these kind of errors, you just say, oh, there was a network error. Let's throw a payment not possible exception or whatever it is. Just rethrow it to our client. And if you do these kind of things, that means you have an upstream client of your payment service that now has to deal with the problem. So you start in the credit card, and the problem gets over and over throughout the whole system. So if you make bigger systems like microservice architectures, but it doesn't have to be microservices. Most of the systems now have a really sufficient degree of complexity where this gets really a big problem. So just rethrowing stuff makes your architecture much more complex. That's an observation we have basically in all customer scenarios. So the important thing is to really what I call be responsible. So if you have an error, you have to handle it. You have to handle it locally, so you have to do something about it. There are different strategies to handle it. Ignorance could be one. Rethrowing is normally not a good idea. Another one is to really handle it. And in this case, one possibility would be what I call a stateful retry. So retry makes a lot of sense for most people. So for example, the credit card service had a network error, so I try it again. But if it's a network, it might not be available for minutes or hours, or the other service might not be available for some time. So you have to retry it for a much longer time. And that's what I call a stateful retry. So you have to make that really stateful. And this is kind of sounds like an easy strategy. And I have a couple of other examples backing that. But what I see in the project is that this is one of the biggest problems. As soon as you say, okay, it's stateful, people say, okay, that's state. Okay, how do I handle state? It's 2018, shouldn't be that hard to handle state. So what's the default strategy? I do what I call a persistent thing. So that's for me, that's a summary of, it could be an entity like a database table, it could also be a document in whatever document store, it could also be a persistent actor or whatever it is. I actually don't care about the concrete technology, how you persist that, but the thing is you have to persist it yourself. And a lot of developers I know back away from that possibility because they sense, okay, there's a lot of effort you have to do additionally, like if I do that persistent, okay, then I have to think about the scheduling of the retry. I have to do that periodically, probably with an increasing interval. Oh yeah, and if there's always something going on, how do I change the logic? Do I need versioning? I want to see all the stock stuff somewhere. I have to operate it successfully. I have to handle it at scale, and so on, so on, so on. So there are a lot of things normally starting to pop up as soon as you do something stateful. That's why we also this whole serverless thing is going on so much, or functions basically, functions as a service. If you do functions, they are normally stateless, and that's much easier to program. But there's a second possibility to handle this kind of state, and that's actually not new technology. I want to reiterate over that. There's a class of tools which are called state machines or workflow engines most of the time. And the thing is, they have a pretty bad reputation. If I say workflow engine, normally what happens is people thinking of, oh, there was this BPM thing ago, like 10 years ago, these IBM and co. Oh no, that was really, really proprietary. It was very complex, unhandy, big stuff. As a developer, it was a nightmare to do. I couldn't code my way away. Normally what happens there is what I call death by properties panel. I have to click through all the panels and cannot code. So that was really, really bad thing. And the important message is that this is not necessarily true anymore. So they're still bad tools, but there are a lot of different things going on at the moment. And if you look at the market of workflow engines, it's very interesting movements going on over the last 1 or 2 years. So if you look, for example, at the cloud vendors, AWS, Amazon, for example, they do something what they call step functions, but the other cloud vendors are doing similar things. That's a state machine. They're doing kind of a workflow engine because they need it in the architecture to solve different problems. If you look at the Silicon Valley stacks, they all do inventing some kind of things. Like Netflix did what's called Conductor. They did that 2 years ago, releasing that more or less. And Uber does something called Cadence. In their own universe, Uber requires Go and Cassandra, which is probably not for the Java guys, not the best solution there. Conductor requires DynamoDB from Netflix, for example. So it's very nailed to their infrastructure. But it definitely shows that there is a need for these kind of things. And but there are also a lot of open source engines available, especially in the Java space, like the ones I have on the slide. I want to show a quick example of what I mean today. By coincidence, I use the one from the company I co-founded, so sorry for that. But the other ones are very much comparable in what I want to show today, actually. So you could, in your head, if you prefer like JVPM or Activity, for example, just replace that in your head. It's kind of comparable. Not that good, but kind of comparable. So let's make a quick example with the payment and the credit card. I use, in this case, Spring Boot. Who's using Spring Boot here? Oh, not that much, actually. Okay, interesting. What's the rest using? Java EE or? No, what's the rest using? Tomcat. Interesting. Okay. The rest is not. Who's using Java? Okay, that's at least. Okay, cool. Probably after lunch, you're not fast enough with raising the hand. That's understandable. So let's make a quick example here. I go to my Eclipse. What I have here is sorry for Eclipse, yeah. I get... I think that's one of the top questions I normally get after the talk. Why are you using Eclipse? And I can answer that. It's my own laziness. I just started with Eclipse. Most of the customers use Eclipse for a time, so I stuck with it because I'm fast with it. I'm not saying it's good, but it does the job for me. But sorry for that. So let's get back to the code. So that's Spring Boot code. So I have a REST controller. What I do is I provide the payment service. Who's doing REST most of the time in his architecture? Anybody doing messaging? Eventing? Really eventing? Okay, interesting. Yep. Most of the people were REST. That's what I see most of the time. So you should be familiar with that. So I have a REST controller, that's Spring. Then I provide a method where I say, okay, you can do a put on the API payment. Then I do a couple of nonsense stuff here just for the demo. And then I charge the credit card. That's the upstream call. Can everybody read the code on the slide? No, yeah, we have that huge screen and the code is so small. That's pretty bad. Let's do that. It's also possible in Eclipse to change the font size. It's not easy, but it's possible. Let's do 28. 28 should do. Let's see. Does 28 do? Yeah, awesome. Good. Let's make it big now. So, okay, awesome. So again, REST controller, we do a put, then we charge the credit card, then I do an upstream REST call. That's normal thing. And what do you do in Spring? You use a REST template, you do a post, you post to an URL, you get back a response, and that's it, right? You probably have done something like this before, I think. Let's make a quick check where you are. What I would expect is that you at least do something. Who knows of a circuit breaker? Awesome. We need more hands next year. Homework, look at circuit breaker. I use Hystrix here. Circuit breaker is if I have an upstream service which is, for example, very slow. The circuit breaker, like in your house, before it burns down, it just switches. And then the call is not done anymore. And it could be as easy as here. I just hook that in a Hystrix command. And then if I have slow upstream service, I just switch and I don't call it anymore. That's very important to also to avoid these kind of situations. Sorry for that. I love this slide, so I have to show it again. So these kind of situations, because only one service is slow, consume all the other thread pools, and so on, so on, so on. Okay. So we can definitely run that code. I have an upstream service here, which I can move to slow or switch to slow. Then I have my Spring Boot service here. Just have to believe me, that's the Spring Boot service. And I can call v1, for example. If my upstream service is slow, that's now blocking. That's pretty bad in reality, so that's what I normally don't want to do. Let's see how long we have to wait. 34 seconds, no, that's too long, so I don't do that. With the With a circuit breaker, I normally get a very fast response, but I get an error. So what the payment service does, it just passes on the error to the client. That's a pretty bad idea. That's what we talked about. So what I can do instead, I can hook in the what I call stateful retry. So what I can do is I can use these kind of state machines or workflow engines. In this case, I use Camunda, but it would be more or less the same with, for example, activity. It would be a bit different with JBPM, but comparable. We have a Spring Boot auto starter, so we can start within Spring Boot, and then we can just wire in the engine. Then we can define a flow. What should happen? The flow is very easy. I'll show you that graphically in a minute. I start. Then the only thing I do is I call the upstream service, in this case Stripe. There's a Spring Bean doing that. That's exactly the code we had before, like doing the REST call. Then I'm done. And the only thing I add here, and this is now what's really cool, is that I now have the state machine, and now I can do the retries. So I have, in this case, like a retry 3 times with a delay of period time 1 minute. But I could do like 1 hour or 2 hours or 5 hours or whatever it is. So now I have a state machine where I can do a lot of things. And then I just deploy that thing to the engine, then it's versioned and these kind of things. That's the Stripe adapter hooked in here. And that's the code, exactly the code I had before, so I haven't changed that at all. And then when I charge the credit card, I hope that's not too fast for you, the only thing I change is I don't do it immediately, but I start a new workflow instance, and this can do the retrying. And if I do that, the behavior changes. So now I have v3. With the stateful retry, I do a send. What you see is I get a return immediately. In this case, a 202 accepted. That's also important. I come back to that in a second. And let's make that also a bit bigger. No, it's not possible to make it any more. Whatever. So I got back a response. And what happened in the background, I mean, the service is still slow and not reachable, is that I can look into, typically these kind of state machines have a dashboard where I can see what's going on. And let's do that. So I look into that one. I see, oh, there's a payment v3. There I have a workflow definition deployed. Oh, there's one instance currently waiting. And I can look into all the details and so on and so on. Currently, there are still retries going on. As soon as I don't have any retries anymore, I get even like an error, an incident within the monitoring. So I get a lot of visibility currently going on. And if I actually get back my service to normal, after some time, this payment service should heal itself and should still process get a result. Now, typically a question is like, oh, but now you switch from synchronous REST communication to asynchronous. Oh, that's pretty bad. Probably, yeah, but there are easy ways to mask that. So the normal behavior, what you could do is like, if everything is fine, you return something synchronously, like 200 OK. And so like this. Still, the workflow engine is doing its job in the background. You don't recognize that, actually. And if it starts to get slow, I switch to asynchronous processing. And that's a pattern, independently of the workflow engine or not, that's actually very valuable in these kind of distributed systems. OK? Make sense so far? Otherwise, shout at me. That's no problem. I got the Eclipse message. That was pretty clear. OK. So, but let's get going. And the cool thing is that now you have that state machine, and that state machine is pretty powerful in order to solve a couple of these challenges we have in distributed systems. And I want to reiterate over that. What these kind of state machines workflow engines can do for you is what I call provide long-running services. With long-running, I mean potentially long-running normally, because that's what I meant. If everything is okay, I'm probably still synchronous, so then it's very, very quick, like microseconds. But if not, I'd probably switch to long running. And long running is very often confusing, means normally I can wait for a long time. I store the state somewhere and can wait. Okay. This gives us new possibilities as well. Now, let's assume not a network error, but let's assume something like a business error. The credit card could be rejected. Let's make that example. So the order service probably want to retrieve some payment, and the credit card service says, no, this credit card is not valid, or there's no money on it, or whatever. The same question again. what do you do in the payment service? You could ignore the problem. That's normally not a good idea with payments, so don't ignore it. You could rethrow it. Okay? And again, this happens all the time. The people are just rethrowing it because they cannot handle it locally. What happens then? Actually very interesting. If you look at typical requirements, not in all cases, but in a lot of cases with expired credit cards, rejected credit cards, you normally give the customer a second chance because he already ordered, for example. So you want to do something like, okay, you ordered your stuff, the credit card is not possible, so please update your credit card details. You get, for example, emails from GitHub. I got that, like, okay, your credit card couldn't be charged, now you have 2 weeks to update the credit card. If you do that, everything's fine, otherwise we block your account. If you do these kind of things, and you just pass it on to the order, then something happens that Sam Newman, he wrote the, in O'Reilly, the microservices book, and there he wrote something which is pretty interesting. He said, okay, what you very often get is that you end up in microservice architectures, for example, if you have these kind of order service, for example, you probably end up with a few smart God services telling all the others, like CRUD services, what to do. And that's from what I see at customers very often happening because they don't have this capability for long running. For example, within payment, they rethrow the error, and that means now the order service grows big because he has to handle all these kind of things. And that should not happen. And so that's the same thing. As soon as you have this kind of long-running capability, you should handle these kind of problems also in the payment service. So the payment service could basically do everything he needs to do, and at the end he says, okay, payment was either received or failed. Done. Okay? But in order to do that, you need these kind of long-running capabilities. For example, in a workflow engine, it could look like this. You have the payment requested, then you charge the credit card. It's not possible. You send the customer email. You wait for configure amount of time. The state machine can track that. And then you either redo the payment or you fail. So these are strategies you have. That's pretty cool. But that's kind of the warm-up for the consistency in transactions, actually. So for me, that's kind of laying the ground because I'm discussing that a lot currently. So from my perspective, I think it's very important to have capabilities for long-running behavior within services easily, because otherwise you end up with a couple of the problems I described. Other challenge, I talked about retries. So I did the retrying, right? I even had the circuit breaker, and then doing the retries. There it was even very easy to see that the request in the backend was processed, but too slow. And that means in the very easy example, I just do 2 payments, 2 credit card charged. That's actually not what I should do, right? Yeah, that's the recap. So that's what I did. You probably, I'm not sure, you probably are also aware of the naming and these kind of things. Let's skip that. So there are essentially two ways of dealing with these kind of retries. There is what's called the at least once semantic, and there's something called the at most once semantic. And it's really important to have these kind of things in mind. So let's go through that. So if I do charge the credit card, and it actually doesn't matter if you use a workflow engine, what I do here in the picture, or if you just write Java code or Go code. The problem is in every distributed system, in every remote call. So if you have 2 things you want to couple together in some way, and you don't have transactions, I come back to transactions in a second, then you have to decide for an order. For example, in my case, I could first invoke the REST API to do the credit card payment. And the second thing is I could tell the engine that I did it, and then the engine can move on. If I do it like this, it could be that the REST request doesn't go through because of a network problem. Then I have to retry. That's what I already said. But it could also be that I cannot complete the transaction for whatever reason. In this case, I cannot complete the transaction there, so that means I will also retry. So in both cases, I will have the risk of duplicate calls. That's why it's called at least once, probably more than once. And that's the normal thing. That's actually the most often used strategy. The other one, that's actually pretty rare, but could be at most ones. So you turn it around, you say, I complete it first. And only if that works, I really call the API. What could happen, obviously, if then something blows up, you don't do the retries. You probably never call the service. Sometimes handy if you, for example, want to send a customer email and say, okay, if we don't send it, it's no problem, but we don't want to send it multiple times. That's pretty bad. But it's not very often used. And there's nothing really in between. So, and it's independent. That's also important of the communication protocol. So it could be REST, it could be messaging. You always have these kind of problems, and you have to deal with them. Now, typically, if we talk about these kind of things, and for example, I make this slide, people start asking, okay, these are two things you want to do, but that's why we have transaction managers. Why don't you couple these two calls in one transaction and give it to the transaction manager? They do exactly this thing. Either both happened or none. That's exactly what we want to have. And that's the bad, or the bad news basically nowadays for distributed systems. There aren't such things as transaction managers. You probably know two-phase commit. Who uses two-phase commit? Oh, really rare. 2 or 3 people. So that's distributed transaction management. There's two-phase commit. There are protocols to do that, but actually nobody uses that. So that's pretty normal to have not a lot of people. And there's a great paper from Pat Helland. At that time he was at Amazon. Nowadays he's at Salesforce. It's from 2007. It's pretty old, but it's very, very accurate still. And it's a really good read. And he describes it very well why these distributed transaction managers, two-phase commit, simply don't scale. And they are very complicated. My personal favorite story for that is actually a Stack Overflow discussion. That's a great discussion. There's a guy asking, okay, I have this JBoss application server. I started up and I got this Arjuna transaction, whatever, warning. Every time I start it up. How do I get rid of that? And then there's an answer, okay, go to that directory, delete all the files. And he answers like, oh yeah, that did the trick, the warnings are gone. Yeah, he deleted the pending transaction. The transaction manager couldn't complete the transaction, then he writes a warning, you have to resolve that manually. Nobody understands these kind of things. So you should have in mind there is no distributed transaction manager, but you have these problems. You had the problem of these two calls. What do you do with the at least once payments? Do you really do payments multiple times? Probably not. So I don't talk a lot about idempotency today, actually, but that's obviously one of the important things to keep in mind as well. What I could do very easily to make the service provider idempotent, that means if I call the charge credit card multiple times, I just do it once. That's one of the most important things you should do, because if you write a new service, it's normally easy to make it idempotent. Very important. You could introduce, for example, a transaction ID or use some correlation ID or whatever to recognize, okay, I already got this payment. Okay, so that's very important, but that's only one part of the puzzle. And the other part of the puzzle is that whenever you are a client, for example, in the payment, and you charge the credit card and you probably even retry it, and after some time you get an error, and you decide, I don't want to retry anymore, this took for 20 minutes, that's enough, I don't get it. Then you can raise a payment failed, but you probably have called the payment service, and that's something that always have to be in your mind. You probably have called it, you have to do something about it. And in this case, it could be, one strategy could be to refund or to query if you have charged it and to refund, but you have to do these kind of things as soon as it gets remote. And there's no real way around it, actually. And that's an important thing. And again, you have to do it reliably. If that's remote, probably the refund is not available at the time you want to call it. And then you have to deal with that again. That gets stateful again. So that's, what I mean. So pretty important to have that in mind. There's a second strategy which is connected to what I just said, which you've probably heard of. That's compensation. Or probably somebody heard of the saga pattern. That's also very well known. And that means that if you're doing a couple of activities in a row, in this case, for example, you could deduct some, first of all, when you do the payment, you deduct money from the customer account, if he has some credit, for example. And if that's not sufficient, you charge the credit card. And then if the charging of the credit card fails, obviously you have to refund his money to the to his credit account, because otherwise he probably will get a bit angry. And that's, for example, what Airbnb is doing. If I book an Airbnb apartment and I use some credit, some voucher, it's immediately invalidated. But if the other peer doesn't confirm my apartment, I get the voucher refunded again afterwards. And this is how it's done with the workflow engine, for example. If I have that failure here, this means I call the compensation. And that means all the activities which have this compensation activity configured and were executed in the past successfully, then this compensation activity is called automatically. And the engine can take care of these kind of things automatically. So you don't have to program that by hand. And this is actually the approach how to deal with distributed transactions in remote systems. There is not a really better approach, so that's normally what you do. Again, it's stateful and can be retried and these kind of things. And then you have, and that's also important to keep in mind, you have this, what you know from transaction management, you have that locally within the service. That's a small hut. Yeah, there you have it. So the customer credit service really have transaction management with the database and all these kind of things, but you don't have it on the overall level. And there you have to do the compensation, and because it's remote, it has to be stateful. And that's a pretty safe architecture to go with in distributed systems, actually. Okay. I actually don't want to go too much into the code here, but one important remark, just to not forget it, because what I did here is I defined that flow programmatically, and I normally start with doing that because most developers I know are a bit afraid of like graphical models, because there could be something hidden behind that graphical model, some complexity I don't see immediately. But obviously you're not forced to write all that in Java. So what you can also do, can define these kind of flows graphically. There's a modeler available, and then you have exactly that, and you can do it graphically, and this one is an XML file underneath, and that's the same thing, can be deployed through the engine, can be versioned, and all this kind of thing, and then you can run that on the engine. We probably jump into the demo later on, but I want to save time quickly for a moment. One thing, I showed these graphical models, and what I use here and what we use in the engine, and most of the other, at least open source engines also use, is BPMN. It's an ISO standard, it's worldwide. I love BPMN, really. Not only because we wrote that book and we sold it around 40,000 times, I think, worldwide nowadays. So it's really quite used standard, but I really love it. It's very mature. I think I have a slide on that, yeah. It's very mature. You can directly execute what you see there. The graphical model is not like a drawing you just print out and then stick on the wall and do something else, but it's really directly executable. It's easy to understand, so what we see is that BPMN models can be understood by developers, but also probably by business folks and also by operations. So if your operations have problems, they can probably even look into the BPMN model directly as well. And it's very widespread, so nowadays you probably have even heard of BPMN. Normally, most people have, but then they think of, oh, BPMN, these complex IBM stuff. No, I don't do that. So this is something you should change in your mind. And then you have all these, what I don't show today, but you have all the visibility, like in our case, it's cockpit, so you can see all like failed instances, you can see what's going on, you can look into the history, what happened in the past, you can have statistics, you can have a lot of information on these kind of things. And if you compare that to, I had it on the slide earlier, to other frameworks popping up like Netflix Conductor, or in this case, AWS, Amazon, what they do is they reinvent a new language. And it kind of hurts me a bit personally, because I'm working with a different workflow engine since 15 or 20 years. And we really put a lot of effort into BPMN to make it really rich and readable and understandable. And doing the same thing with step functions, for example, is really hard. And some parts of it, I already see a couple of problems they will run into with a limited language. So that's why I think BPMN is really a good choice to do these kind of things. And it's very powerful, but we don't go into these kind of things. Okay. Let's get a bit more concrete. I have a couple of links at the very end. I also blogged about how to really do that, how to run that workflow engine for different use cases. And one very important thought is what I did here, and it was probably a bit not that easy to see, but I started the workflow engine as part of the Spring Boot project as part of the payment service. So it's an implementation detail of that payment service. A lot of people, if you say state machine workflow engine, think of some central component you run somewhere, and then you have to talk to it. That's not necessarily true. So you can run it as part of one service, like the payment service. And if you have like another service having these kind of state requirements, you can also do it there. So that's an important message here. And another thing, because normally when I show this order service over there, some people think of, oh, this is kind of, okay, you orchestrate other services like the payment and inventory, so you want to do that overall order service, okay. But orchestration has a bad reputation recently, so I'm not sure about what you think about that, but most people I currently discuss with have this architecture idea in their head of avoiding central components, avoiding like peer-to-peer communication, avoiding central orchestration in favor of peer-to-peer communication. So for example, in order to do like this order process, like you pay first, you fetch the items, you ship the goods, you want to have these different components talking to each other, for example, via events. That's one of the one current idea, which is very, let's say, very much used recently in a lot of discussions. And a lot of people are in favor of this approach. But what happens, and we saw that happening at a couple of customers, is that you lose the view or the overview of that process, of that workflow, how that really works. And even Martin Fowler, you probably heard of Martin Fowler. He writes a very famous blog, wrote a couple of books, and he wrote in a recent blog last year, the danger is that it's very easy to make nicely decoupled systems, in this case with event notification, but the thing is peer-to-peer communication, without realizing that you're losing sight of a larger scale flow and set yourself up for trouble in future years. So that is kind of a problem, and that's, again, a thing. What I had earlier also with Sam Newman, so we have to extract this responsibility for the order, which, by the way, can also do the overall order transaction, so the saga, the compensation I had earlier for the order can be steered within that component. So it doesn't have to be something central there. And yeah, and then it looks a bit different. And what I currently see a lot of customers running into is that these, okay, obviously I'm opinionated, so I'm the state machine guy somehow. So I'm seeing state machines everywhere. But I love this kind of things, and what I currently see is that you can use this kind of technology for different use cases. I wrote about that on the news stack, and this is basically, you got a kind of a compilation today. I think as soon as you have this long-running behavior, the state machine, you can use it for, most of the people would think about business processes like the order process. Okay, that's one use case, and it's very valid, and it makes a lot of sense. But I also see it very much used at this kind of transaction management, compensation saga. So that's a great use case for this kind of technology. But you can also obviously orchestrate microservices, or what I have with the communication and distributed systems is what I said with the stateful retry. So there are a lot of things, especially because like remote communication is unreliable, you have to take care of, and there you will run into a lot of stateful problems, actually. That's the observation I make. Of course, my opinion, I did personal view on that. So More concretely, architecture. I can run multiple engines and multiple services. Okay, that sounds nice. How do I do that? One possibility, what I showed, so you could run Spring Boot. Spring Boot could run an engine in case of the Camunda engine, or the others on the slide earlier on. They persist in a relational database. And then if you have multiple services, you run multiple engines. If you don't have Spring Boot, you can run that in a container like Wildfly or WebSphere or WebLogic or whatever it is. Also pretty much possible. So that's very easy to do on a Java perspective. Doesn't have to be like a central thing, a remote thing, or whatever. If you're not in Java, you can run it as a remote thing. There's a REST API. We have a lot of C# or .NET customers recently doing that. That's, of course, possible as well, but just a side note. Quick poll, do we have time for that? Yeah, last thing we have time for. Who uses a message bus? That should be the same people who said earlier they're using messaging. Yeah? Oh, yeah? Keep your hands up if you have no problem operating the message bus. Whoa, 2, 3. 3 people, that's more, 4. That's more than normal. That's amazing. 2018, I ask that very often actually in different talks. 2018, 4 people out of a couple of hundred probably. No problem operating a message bus. The problems I see are always the same. Whenever you have a message bus, and I think personally, by the way, that asynchronous communication is probably a better way to approach a lot of the architectures than REST-based architectures, but that's a different thing. I'm also fine with REST. But if you have message-based architectures, still, you have these kind of problems. You have dead messages. Okay, messages that cannot be delivered where there was an exception. Then they normally end up in a dead message queue. There, you cannot, in most of the tools, you cannot see anything. You don't have a context. Where does this message come from? Why is it there? How can I redeliver it? What was the payload? How can I see the payload? Can I change the payload? People start building a lot of tools around that, very often called something like message hospital or something like that. That's a pretty bad idea. So what we also see used recently is that, for example, if we have the architecture like what I had with the state machine, calling something actively via REST, what I did today, or sending a message to a message bus. What you could also do is you can turn the communication direction around. So you can ask for work as a service. That's what you normally do from the message queue, ask for work, ask for messages. And we have customers using these kind of engines for that because obviously, like these workflows you saw, they can distribute work. The different services can be like, this is kind of a queue, there is some work on that service task, call me if you want to do it, call me if you're done. So that's kind of also very flexible, and then you get a lot of these tooling around what I said earlier. That's also if you're talking about sagas. There's a great talk. If you're interested more into sagas and distributed transactions using Saga, Katie McCaffrey had a great talk on the Code on the Beach. I think it was last year in Malaga. It's on YouTube, so you can watch it on YouTube. She talks about the Saga algorithm, basically, and how to implement these kind of sagas. And she's very much in favor of what she called the Saga executor component in the very middle. It says, okay, it would be much easier for most of the architectures if we have that Saga executor coordinator in the middle, but she doesn't, or she's not yet aware of something that it's really scalable to do that. And the cool thing is that, and I also see that at various projects, that they start to think about having something like a central, let it be orchestrator or Saga coordinator or whatever you want to call it. And we are approaching these kind of things. So obviously Amazon does something under the hood, but that's cloud. You have no idea how they do it, but they do it on a scalable way. And what's also available with the CB that's probably interesting, it's open source projects. We kicked that off last year, and there we do a horizontally scalable workflow engine based on event sourcing. And there we can do from the load more or less what also Kafka can do. So it could do like push every Kafka message to CB. That would work from a load perspective. And that removes a lot of the disadvantages you normally have with these kind of central things, and that would also allow to have these like a central Saga coordinator in order, for example, to steer all the transactions there. Kind of interesting thing. But, okay, summary. So from my perspective, opinionated view, again, I think for the client you have to think about long-running behavior. That's very important because remote communication, you have no idea what the network is doing, what the peer is doing. Probably stateful retry, you definitely have to think about compensation because you don't have a transaction manager. Distributed transactions don't work like two-phase commit or three-phase commit. The service provider has to offer compensation methods, obviously. Most of them, that's for legacy applications, that's one of the biggest problems. Most of them don't offer these compensation methods to undo something. And you should build everything idempotent. That's also very important. Okay, hopefully I'm not too fast. There's one last strategy, which I just want to give you a very quick teaser, but I think it's important to keep that in mind. Also, Pat Helland wrote about that. I'm a big Pat Helland fan, actually. You can also watch a lot of his talks on YouTube. It's kind of fun. I like the guy, actually. And he wrote that it's very famous, memories, guesses, and apologies. And that's actually what you also have to do in that world. If you don't have a consistent, always consistent view on the world, it might be that you make wrong decisions. Like, I booked a flight 2 days ago to New York, and Lufthansa said, oh, there's this last seat available for only 400 euros. And I selected that, clicked on the next page, clicked on paid, and then they said, oh, sorry, there's an error, this seat is not available. These are these kind of situations that happen. But it doesn't matter, you probably just have to apologize. You probably have ordered something at Amazon, and then it's not in the warehouse. Then they apologize. That happens. Inconsistency are kind of normal in these kind of situations. But then it will be good. It's kind of cool. Last quote. Not sure if you know this guy. Martin Kleppmann, he also has written a book on O'Reilly, a very good book, Designing Data-Intensive Applications, released, I think, this year or end of last year, really good. And he had a talk in 2015 with a quote I really love. He said, every sufficiently large deployment of microservices contains an ad hoc, informally specified, bug-ridden, slow implementation of half of transactions. So that's the world we're currently living at. And I think it's still true. And that's why I think it's so important to be aware of that. So we have distributed systems. The first REST call starts your distributed system. Probably ignorance is a good strategy, but probably not. So you have to be aware of these challenges, like you have no idea if you reach the other peer, if he does the work, if you get it duplicated, if it gets retried, and these kind of things. So know these kind of challenges and decide consciously for a strategy. Might be ignorance, might be long-running behavior, might be compensation, might be apologies, but it's very important to have this at hand and to make a good decision about that. And then you probably need tooling to do that. That's obviously the case. Okay. Thank you. I'm still pretty good in time. Okay, awesome. This is a slide with the links. I put the slides online as well. So there's an InfoWorld article on these on the pitfalls, which kind of summarizes a couple of things I did today, and I wrote an InfoQ and NewStack. There's my email address, my Twitter handle. If there's anything, just let me know. Tweet me, ask me, and I hope that was kind of enjoyable. Yeah, was good. Yeah, thank you.